Okay, the derivative is 1 minus x squared. Given a point, find f at x. So we need to integrate 1 minus x squared, which is going to be x minus x cubed over 3. So add 1, divide, plus c. So this is what f at x is going to be equal to, because if you take the antiderivative of the derivative, you get the original function. Okay, so we have f at x equals this. So now we've got f at x is, f at 3 is 0. So we're going to have 3 minus 3 cubed over 3 plus c. So this is going to be 3 minus, that's 27 over 3, 9 plus c. So that's negative 6. So c has to be 6. So don't forget to write the function x minus x cubed over 3 plus 6. All right, so we have the derivative is that, and we've got a point. We do the same thing. Integrate the derivative function to give you the original function. So we're going to have x to the 4 over 4 plus 2x squared over 2 minus x plus c. And then we've got y is 13 when x is 2. So 2 to the 4th over 4. I'm going to cancel those. 2 squared minus 2 plus c. So that's 16 over 4 plus 4 minus 2 plus c. So 8 minus 2 is 6, and then subtract that to the other side, 7. So we've got f at x equals x to the 4th over 4 plus x squared minus x plus 7. All right, we've got, it passes through this point. Okay, so again, we want to integrate. So we're going to have x cubed over 3, so the 3's would cancel, minus 5x plus c. And we're going to have 6 equals 2 cubed minus 5 times 2 plus c. So 8 minus 10 is negative 2. Add it to the other side. C is 8. So we're going to have f at x is x cubed minus 5x plus 8. So we have the derivative is cosine. We've got a point. We integrate. So this is going to be sine x plus c. So we're going to have negative 2 is sine pi over 2 plus c. So sine pi over 2 is 1 if we subtract 1 to the other side. So we're going to have f at x is sine x minus 3. All right, we've got a point. We've got the gradient function. We integrate. So that's going to be negative 2x squared over 2 plus 3x plus c, and then we're going to have 1 equals negative 1 squared is 1 plus 3 times 1. So that's going to be 2, subtract 2 to the other side, we get negative 1. So f at x is negative x squared plus 3x minus 1. All right, 25, we've got to do the same thing. 10e to the 2x minus 5. Oops, dx I meant. So we're going to have 10e to the 2x divide by 2. Remember, e is the same derivative and antiderivative, and then you just have to divide by the derivative of that inside function. It's just substitution. Then minus 5x plus c, and we're going to have 8 is the y. That cancels to 5. E to the 2 times x is 0, minus 5 times 0 plus c. That's 0. This is 1, so we're just going to have 5 plus c, so subtract the 5. We've got 3. So f at x is 5e to the 2x minus 5x plus 3. So this one takes it one little step further. We want to find y when x is 1. So we have 5e to the 2 minus 5 plus 3. So 5e squared minus 2. All right, 26, we've got the derivative of this function. or the derivative of the function. We've got a point, so we're doing the same thing. F of x equals the integral of 1 over 1 plus x minus 0.5 sine x dx. Okay, so we have that this is going to be natural log 1 plus x, and we would divide by the derivative of the inside thing, but it's just a 1 here, okay? So then we have minus 0.5, and we've got negative cosine x here plus c. So now we've got 2 equals natural log 1 plus 0, so 1, minus 0.5, plus, because the two negatives, cosine 0 plus c. So cosine 0 is 1. This natural log 1 is 0 because e to the 0 is 1. Oops. And then, so this is just going to be 0.5. So we subtract 0.5, that's 1.5 is c. So we have f at x equals natural log 1 plus x plus 0.5 cosine x plus 1.5. All right, the derivative of the function f is given by that. The graph passes through that, so we're doing the integral again, e to the negative 2x plus 1 over 1 minus x dx. So here, e is e, but we have to just divide by the derivative of the inside function. This is natural log 1 minus x, and we have to divide by the derivative of the inside function. So now we're going to have 4 equals e to the 0 is 1, so this is going to just be negative 1/2, minus, because of the negative 1 on the denominator, natural log 1 plus c. That's 0. So we're just going to have 4.5 is c. So f at x is negative 1/2 e to the negative 2x minus natural log 1 minus x plus 4.5. Okay, so we've got the same situation. We have to find the antiderivative of the derivative, and that's going to be negative cosine, and we divide by the derivative of the inside. So we're going to have 4 is negative 1/2 cosine 2 times 3 over 2 is 3 minus 3, so 0, plus c. So cosine 0 is 1, so we add 1/2 over, so we get c is 4.5. So we're going to have negative 1/2 cosine 2x minus 3 plus 4.5. All right, 29. We've got the derivative, so we have to write down the second derivative. So that's going to be 2 cosine 5x minus pi over 2, and then we multiply by the derivative of the inside function. So that's 10 cosine 5x minus pi over 2. And then we want to integrate because we want to go back up to the original function. So 2 sine 5x minus pi over 2 dx. So we're going to have 2, and this is going to be negative cosine 5x minus pi over 2, and then we divide by the derivative of the inside plus c, and then we have 1 equals negative 2/5 cosine 5 pi over 2 minus pi over 2, which is 4 pi over 2, which is 2 pi, plus c. Cosine 2 pi is 1, so we just add 2/5 over, so that's going to be 7/5 is c. So f at x is negative 2/5 cosine 5x minus pi over 2 plus 7/5. All right, 30. We've got the derivative as that, and we want to find the function. So we have f of x equals 2e to the negative x plus 10 sine 5x plus 1 dx. So we have 2e to the negative x divided by negative 1 plus 10 negative cosine 5x divided by 5 plus x plus c. And then we have 5 equals, e to the 0 is 1, so we're going to have negative 2 here, plus, actually minus 2, and then 10 over 5 is 2, cosine 0 is 1, so just that, plus 0 plus c. So that's negative 4, so plus 4 over is 9. So our function is f of x is negative 2e to the negative x minus 2 cosine 5x plus x plus 9. All right, we've got the second derivative, and we want to go all the way back up to the original function if there's an inflection point. So we have a max at 1, 5 and a point of inflection at 0, 3. Okay, so that means if there's a point of inflection, the second derivative is equal to 0 when x is 0. So we are going to have b is 0. All right? So then if we integrate to go back up to the first derivative, plus 0 dx, we're going to have 6ax squared over 2 plus c. A lot of people are going to think maybe a is a variable. It's not. All right? Only x. So then we have that we can use 0, 3 or 1, 5. I'm just going to use 0, 3. So that's 3a 0 squared plus c, so c is 3. If we would use 5 equals 3a 1 squared plus c, yeah, that doesn't get rid of the a, does it? So that's not helpful. Okay, so now we have the first derivative is 3ax squared plus 3, and we wouldn't obviously use this one because that will get rid of the x, but we can use 5. Oh, no, sorry. We have, it's a maximum at a, so we have, it's going to be, the first derivative is 0 at x equals 1. So that's going to be 3a plus 3 is 0. So subtract 3, divide by 3, a is negative 1. So now we have the first derivative is negative 3x squared plus 3. And now we have to integrate to find the original function. So that's going to be negative 3x cubed over 3 plus 3x plus c. And we can use this, or 0, 3, that's fine too, to find c. So that's going to be negative, so if x is 1, it's going to be negative 3 over 3, which is negative 1, plus 3 plus c. So that's negative 1 plus 3 is 2, minus 2, so c is 3. And you would have gotten also if we would have used 3 equals with the b point, the 0, 3, and x is 0, so we would have gotten c is 3 too. So final answer, f of x is negative x cubed, because those will cancel, plus 3x plus 3.